Hi everyone, we are on circles and metalworking and this is section 8.4. Here's some information about circles. The radius is the distance from the center of the circle to the outside. You can see that right here on our circle. All right, that's our radius. Well, I guess I circled more than just the radius. From the center of the circle to the outside is our radius, all the way across, diameter, right? And it also has to go through the center. And then the circumference is the distance around the circle, which that's similar to perimeter for a polygon, but we call it circumference when it's a circle. Here are some of our formulas. And so you can see that if we take the radius times 2, we get the diameter. Or if we divide the diameter by 2, we get the radius. And those are things where you should just be able to go back and forth. If you know the radius, it's easy to find the diameter or vice versa. The circumference is pi times the diameter, or 2 times pi. Oh, come on. 2 times pi times the radius. So that is our other formula for circumference. And once again, you can use either of those formulas depending on what you're given, or you can divide or multiply to get the other, right? If you have diameter, you can just divide by 2 to get your radius. Radius times 2 to get your diameter. Pi comes from this calculation, the circumference of a circle divided by its diameter. Now this is true for every circle, but that means that your measurements have to be very perfect for that to be the case, but that's where pi comes from. And then area of a circle is pi times the radius squared. Now there's also one using diameter. I just never use that one, so I don't talk about it. I don't even remember exactly what it is, to be honest. Now we're going to do a little bit of practice here. Now, you'll notice that we have 14 inches. That's from the center of the circle, so that is our radius. Now, if we did need to know our diameter, it would just be 2 times 14, which is 28 inches. And then if we had this, we already knew the circumference, we could actually use that formula and solve for R or for D, either way. So find the circumference. We're going to use 2 times pi times the radius, or we could have used just pi times the diameter since we talked about that. But I want you to know that if you have, on this we're going to put in 14 for our radius. Now you have a pi key. It says use the pi key for pi and round to the nearest tenth. That's your answer. The pi key is on your calculator, and so you'll have to just find that. For the one that we recommend for this class, the pi key is, let's see, 1, 2, 3, the 4th button down on the left. So you can see that that's 28 times pi, right? 2 times 14, and our circumference is 87.96. Now it told us to round to the nearest tenth. When we round that, it is 88.0. Now we have to put that 0.0 because we were rounding to the tenths place. All right, so area is pi times the radius squared. So pi times 14 squared. 14 squared is 196. And then we're going to calculate that using our pi key. 196 times pi, 615.75. When we round that, it's 615.8. And that is in square inches because we are still talking about area. So all areas are going to be in square units, whatever the unit happens to be. All right, there's our first practice with that. Now on this one it says find the area of the figure, and that's talking about that blue ring that you see here. And so we have to think about, okay, how do I find the area of just this blue part? And once again, we're using the pi key for pi and rounding to the tenths place. Now, we have two circles here. We have the circle on the inside, and you can see that the radius of my smaller circle is 18 centimeters. And so the radius of my all the way to the outside would be 20 centimeters because we would add 2 to that radius. Now what we're going to do is find the area of the big circle. So pi times 20 squared, and then subtract the smaller circle, and that's pi times 18 squared. All right, so here's one radius, and then my other radius was, for some reason that's being weird. So we have to use both. Find the area of the whole thing. So that's what's happening when we take it times the 20 squared. And then we're finding the area of the smaller circle when we take it pi times 18 squared. And when we subtract, that's just that little ring on the outside. All right, so 20 squared is 400. So we have 400 times pi minus 324 times pi. 18 squared is 324. And then you can just key that into your calculator, right? 400 times pi minus 324 times pi. And let me make the wavy equal sign here. So 238.76. And we're rounding to the tenths place, so I write it like this so that I can round appropriately. Right? Oh, that is what I wanted to do. Underline the 7. I'm pointing at the 6. That tells me that I'm going to add 1 to the 7. So 238.8. This was in centimeters. So we're in centimeters squared. Now, one thing you'll need to pay attention to as you work through problems is that if it tells you to use 3.14 for pi, be sure that you do that, because there will be a little bit of difference there because the 3.14 is rounded. So I kind of like just using the pi key personally, but sometimes the problems will tell you otherwise. Okay, so here's another one where we're going to find the area of this blue part. And we have to first talk about, okay, what do we have here? Well, the outside part, it says find the area of the figure. The outside part is a hexagon. So we're going to find the area of the hexagon, and we're going to subtract the area of the circle. So it's the hexagon minus the circle. It gave us the length of the side, which was nice, so we don't have to find that. You know, sometimes it gives us the distance across the flats, or the what's the other one, or the points on the side, the corners. And so whenever we have that, it takes a little bit more work. But in this case, we can see that A is 3/4 of an inch. That's the length of the side of the hexagon. And our radius for the circle is 1/2 inch. So here's our formulas. We're going to use the formula for the hexagon. That's on your formula sheet. 2.598 a squared minus the area of a circle, which is pi r squared. And then we can substitute in our numbers. So for A, it is 3/4. And then, you know what, let's just go ahead and make that 0.75. So 0.75 squared minus pi times 0.5 squared. So the 1/2 is 0.5, and of course 3/4 is 0.75. I think most people know that just, you know, without even having to calculate. And then we have to be careful with our calculations and rounding. So I usually write out quite a few decimals just to be on the safe side, but not all of them. So this one is 1.461375, and then the other one is 0.785398. So just write out quite a few, or just calculate it all at once. That's the other thing that you could do. You could just key this in. like that, and then you wouldn't necessarily have to write the step that I just wrote. We're rounding to the tenths place again, so now I have 0.676, and that rounds to 0.7. It's square inches because we're working with inches here. And it's very small, but you can see that this figure is very small because it has a radius of a 1/2 inch and the length of the side is 3/4 of an inch. All right, here's our next one. So we have to identify what in the world is this thing. Well, if you put a line across here, then I think you can actually see that that is a trapezoid if we kind of ignore that semicircle. So we're going to take the area of the trapezoid and subtract the area of a semicircle. Now we are talking about areas here, right? So for my trapezoid, I have to figure out my bases. Well, I have a base of 46 feet, and my bottom base is 51 plus, right? That's my radius. So my radius is there twice, so 32 and 32 feet. I have to add those all together. So my first base is 46 feet. Base 2 is, it doesn't matter which base is which, by the way, 51 plus 32 and 32 are 64, and then 51, and so that would be 166 feet. So I have to identify my bases. My formulas are going to be the area of a trapezoid, and here's the formula for that, minus the area of a circle divided by 2, because a semicircle is half a circle. And whenever I have a semicircle, then I just use the same circle formula, but divide it by 2. And then we just substitute everything in and calculate. So we have 46 plus 166 divided by 2 times our height. It tells us our height over here, so that's 91. And then I have pi times my radius. My radius was 32. My radius squared divided by 2. So you can see this is quite the calculation. Whenever I calculate my parentheses, right, 46 plus 166 divided by 2, that's 106 times 91. And then on the other, if I take 32 squared divided by 2, I didn't write down 32 squared. 32 squared is 1024. And then when I divide that by 2, it's 512. So 512 times pi. So I would suggest doing some of the the calculations on the in-between part. And then if you want to key it all in, you can. From here, I get 9,646 minus 1608.495. Don't forget to pause, when you're working through these so you can practice this. When I round this to the tenths, it's 8,037.5 square feet. So this one could have been a little bit tricky, especially because you had to be real careful with this base number down here and making sure that you identified everything. You had a semicircle, and that's just those kind of things are going to show up in different problems that we do. All right, I'm going to stop this video and then we'll pick up the lesson on the next video.